So from this we are getting this boolean function is converted to the product of maxterm. So you know the difference, right? What how to represent a boolean function in sum of minterm and how to represent a boolean function in product of maxterm. So sum of minterms is nothing but it is represented like this. Okay, that we can call it as the product of sum. Okay, so that means here we can call it as the sum of minterm, we can call it as the sum of product terms. That means, so the sum is the highlighted point and in between each variable we are having the product. Okay, so that is representation of sum of minterm. So here product of max term is nothing but, so whatever we are taking the first example, that is equal to the, I am taking this equation xy plus x complement z, but just check it is in product of max term or not. What is the procedure to finding any boolean function in product of max term means, so what is the first step? Check the boolean function is in product of max term or not. Whatever we are taking, whatever we are considering the boolean function, so first we need to check it is in product of max term or not. Okay, so how to represent this equation is in product of max term, how to find it, it is it in product of max term means, how to define that boolean function is in product of max term means, so that is nothing but, that boolean function is nothing but having the or terms. Okay, we can represent it as product of or terms. Remember it, product of maximum is nothing but it is the boolean function can represent it as product or terms. Product of or terms. Here sum of minterms is nothing but that will be represented as sum of product terms. That's why here sum we can represent it as in between each term. Okay, and product can define as in between any variable will define that, in between two or three variables will take it that product term, and in between each term, that is term is different and variables is different. Okay, in between each variable is nothing but we are defining the product here, and in between each term we can define the or operation. So but here exactly opposite, product of or term. So here compulsory whatever the boolean function we are consider here, that is in the form of product of or terms, but here product is not there and here or is not there. Okay, so that is compulsory, this equation cannot consider as product of max term equation. So how to, if the equation, if the boolean function is not in product of max term, so what is the procedure to converting product of max term for that equation? Okay, how to, what is the procedure to find it, how to procedure, what is the procedure to convert this boolean function into product of max term means, just whatever the boolean equation we are having. Okay, so first we need to convert that equation into product of max term by using product of x into x complement logic. Okay, so here we can must and should we can use the distributive law. Okay, first we need to use distributive law, after that the boolean function can be expanded by using this distributive law. So after expanding that distributive law, by using distributive law, after expanding the boolean function, so just check it if any missing variable will be there. Okay, if any variable is missing in that boolean function, just check it. Okay, each term having the all the variables or not, first check it. Okay, so conversion is completed by using distributive law, already you know from this uh, description, that is nothing but here whatever we are using the rule. So from this we are converting that equation into like this. Now check it, this is in actually sum of minterm equation, directly I can convert into product of or terms, this product and or term. Okay, so after finally completing of converting of product of max term, what is the next procedure? So what is the next procedure is nothing but all the variables are not or present or not in each term, all the variables are present or not, check it. So in each term means this is a one term and this is the one term and this is a one term. So in that one variable is not there. Actually how many variables we are having? X, y, z, three variables, right? But in that first two variables, first term z is not there, and in the second term y is not there, and in the third term x is not there. Okay, so what is the next step? If any missing variable is present in that if any variable is missing in that boolean equation, so what is the next step means, that any missing variable is present in the term, so that variable is odd with x into x complement, that is added with x into x complement. If any variable is missing here, y z is missing, no, that z is added with like this. The z logic is using product logic, so z into z complement can be added with this each term. If any missing variable is present, that is ORed with. ORed is nothing but added. Okay, addition, right? Added with that logic. Okay, so I can add it here. So f is equals to, here z is missing, no, y plus x complement plus z is not there. I can go for this logic, z into z complement, like this way. Here also one variable is missing, no, in sum of minterms. What we are doing here, if any variable is missing, so just ANDed with this logic. If any variable is missing, that variable can be ANDed with this logic. Okay, so like this. Here b and c is not there, so directly I will go for this logic, b plus b complement and c plus c complement. Like this way I can go for this logic, is nothing but OR logic with x into x complement. Okay, so like this. And the next one is x plus, here y is missing, so y into y complement plus z. Next, in third term, x is missing, x into x complement plus y plus z. Okay, now simplify this part. Okay, so f is equals to the first step. So here y plus x complement plus, I can rewrite that equation. So x complement plus y plus z, z complement, z into z complement. Okay, so the next equation becomes, next term, x plus y into y complement plus z. Okay, so the next term is x into x complement plus y plus z. Okay, so again here we are converting distributive law actually. So that distributive law is nothing but, how to define that distributive law? Any product term will have, that will be divided into two parts. Okay, like this, x plus y into x plus z. Okay, so here also we are converting, here z into z complement, this is one of the product term, and here also y into y complement, here we'll have the one product term, and next here x into x complement. Okay, we'll define that product into two terms. Okay, so that means x complement plus y plus z into z complement. Okay, I will rewrite this equation like this, into x plus z plus y into y complement. Okay, the next step, next term, that is nothing but x into x complement plus y plus z. Okay, so I can rewrite this equation like this. So here x plus y plus z is one term, and the next one again will have the another term. So like this, x complement plus y plus z, this is the first term for this, and the next one, by using distributive law we can separate this. Okay, x complement plus y plus z complement. Okay, so now we'll go for the second term like this, x plus z plus y into x plus z plus y complement, into next x plus y plus z into x complement plus y plus z. Okay, so now rewrite this, x complement plus y plus z, x complement plus y plus z complement. In between each term we'll have the product, x plus y plus z, x plus y complement plus z into x plus y plus z and x complement plus y plus z. So now check it, x complement plus y plus z, is it repeated? Once check it, x complement plus y plus z. Okay, so it is repeated like this, x plus x is equals to, we'll write it only single x. Okay, like this, 1 plus 1 is equals to 1 na? So like this way we can consider, in between these two terms we'll add it only single one. Okay, so that means we can consider as two terms will be one term, x complement plus y plus z. And next one, here x complement plus y plus z complement, is it repeated? So it's not repeated, directly you can write it the second term as it is. Next, in third, while coming to third term, x plus y plus z, x plus y plus z. This is repeated, so you can take one term. And next x plus y complement z, so it is also not repeated, so directly you will take it. Okay, so finally we'll get the equation becomes like this. Okay, so now this equation will be converted to the minterm or maxterm equation. Okay, so just check it, is it minterm equation or maxterm equation. So then we'll go for the how to represent a minterm equation and how to represent a maxterm equation. We'll go for that. Okay, already knows how to represent as we discussed in the previous classes. Okay, so this is dot, that means product of sum. So where we are getting product of sum? Here, product of sum, that can be represented as maxterm equation. Okay, so that means this is in maxterm equation. So in maxterm, how to represent a zero and how to represent a complement and how to represent a normal term. So that is nothing but we need to check it in maxterm. This is maxterm. So how to represent a zero, normal, and how to represent a 1, complement. So that means complement will be 1, where we are having the complement, that will be represented as 1, and where we are having the normal, that is will be 0. So 1 0 1 1 0 0 0. Okay, so normal will be 0 na, 0 1 0. So from this we need to write it maxterm values. Okay, so 1 0 0. First here triple zero na, triple zero is nothing but starting point, that we can represent it as m naught. I can consider here. Okay, or otherwise you can rewrite that value. Okay, so I can rewrite this equation becomes like this, x plus, in order wise I can write it now, x plus y plus z, and next after triple zero, 0 1 0, x plus y complement plus z, and next then we'll go for the first one, x complement plus y plus z, and the next one is x complement plus y plus z complement. So now write it values 0 0 0, 0 1 0, 1 0 0, next 1 0 1. Okay, now write it maxterm values, that means designation values we can represent. Triple zero is nothing but how to designate this value, m naught into next 0 1 0, m2. Okay, so 1 0 0, that is m4, m1 0 1, that is nothing but m5. Okay, we need to check it in truth table, is it right or not. Okay, this is maxterm. So triple zero we can represent it as 0, and next 0 1 0 we can represent it as m2, and 1 0 0 we can represent m4, and 1 0 1 we can represent it as m5. Okay, so this is the product of maxterm. What is the procedure to convert any boolean function into product of maxterm means, so by using distributive law and by using any missing variable will be present in that. So by using this logic, or with x into x complement. Okay, added with any variable is missing in any term, so just this term will be, this logic is added to the term. Okay na, so this is the procedure to find it product of maxterm of the any boolean function. Okay, so how to represent a product term? Here summation can be represented as like this, no, in sum of minterms we can represent summation is like this. After we are getting m1 m4 m5 m6, that means minterm values, so we are converting into particular symbolic representation, that means summation symbol we are taking. Sometime convenient to represent this sum of minterms is like this. In this way, a convenient way to express the function is as like this, f of, so how many variables we are taking, which variables we are taking, 3 variables, those are x y z. So f of x y z is equals to, the product symbol is like this. Okay, just like pi. Okay, so the next we need to represent as binary variables of the designation, so 0 2 4 5. Okay, so the product symbol pi denotes the ANDing of this pi, denotes the ANDing of max terms, and the numbers or the max terms of the these numbers are can represented as that is nothing but decimal numbers. Okay, this 0 2 4 5 can represent as decimal equivalent of the binary numbers of the maxterm. Okay, so this is the procedure to finding sum of minterms and product of maxterm. So the combination of product of maxterms and sum of minterms, we can call it as the canonical form. Okay, so what is a canonical form? So the combination of sum of minterms or product of maxterm, we can call it as the canonical form. So what is sum of minterms and what is product of maxterm means this is the procedure. Okay, so now we'll go for the next method, that is nothing but, so this is complete explanation about canonical form. Okay, in canonical form we are discussing, we have to discuss, that is nothing but minterms, maxterm and product of minterm, product of maxterm. That complete topic is related to the canonical form. Okay, now we'll go for the another method, that is standard form. Okay, so what is standard form means, now we'll see that standard form. Okay, okay, so now we'll see what is meant by standard form. So standard form is nothing but the combination of sum of product, the combination of sum of product and product of sum, product of sum. Okay, so what is standard form means the combination of sum of products and product of sum, or okay, so the combination of sum of product or product of sum, we can call it as the standard form. Okay, so now we'll see, what is meant by sum of product and product of sum. So then we'll go for the first one in that, that is sum of product. Okay, so the sum of product is a Boolean expression containing the terms. Okay, so the sum of product is a Boolean expression containing the terms that is called as product terms of one or more variables. Okay, what is meant by sum of product? So whatever that Boolean expression that is expressed in product terms. Okay, so that means any Boolean expression, that may be f is denoted. Okay, so this Boolean function expressed in the form of product terms of one or more variables. Okay, so that is called as the sum of product. So I can express one example here. I can consider one example for this sum of product, that is like I can take some y complement z plus x y z plus z complement. Okay, so like this we can represent the equation in the form of sum of product. Okay, just observe here what I meant. What I meant say here, f is equals to, that means the Boolean function can be expressed in the form of product terms, like product terms, each term having the product of in between two variables or three variables. Okay, so just check it, in between these three variables will have the product, in between these two variables will have the product. Okay, and also having the OR logic, that means the product terms of one or more variables having the OR logic. Okay, so here the Boolean expression containing the terms that may be variables in the form of product terms with the sum, or OR logic. Okay, so the sum denotes the here ORing of these three terms. Okay, so this plus can denotes as sum or OR logic, and in between each variable we are having the product term. So this we can call it as the sum of product. And now we'll go for the product of sum. Okay, so product of sum, that means how to represent a product of sum means, so the Boolean expression containing the OR terms, here the Boolean expression containing the AND terms is nothing but product terms. Okay, so here the Boolean expression containing the OR terms, that means sum terms. Okay, the Boolean expression containing the sum terms or OR terms, we can call it as like this. Okay, each term may have any number of variables or n number of variables. That product can denote the ANDing of the terms. Okay, handing of the terms is nothing but I can just take one example here. F is equals to some x into y plus z complement. Okay, and into, so x plus y plus z. Okay, so this is the best example for the product of sum. How to denote a product of sum? So the boolean expression in containing the terms, we can call it as the sum terms, and that can be expressed in the form of AND logic. AND logic is nothing but like this. And this is the boolean expression in containing the product terms or AND terms, we can call it that sum is in OR logic. Okay, so here we can represent sum and here we can represent product. In between each variable we are having the product in this, and in between each variable we are having the OR logic, that means addition. Okay, so this is, we can call it as this procedure we can call it as standard form. Okay, so finally this is the complete explanation about canonical form and standard form. Okay.